that. Okay. Yeah. So I guess why don't we get going? So yeah, you've had three of the assignments or the old exams, 2001, 2002, 2003. You haven't really had time to do all of them, maybe, or maybe you have, I don't know. But I thought I'd go over a selection of those problems based partly on what you want to hear from, and then based partly on what I choose maybe as well. Is that cool?
Yeah.
Sounds good.
Okay, how were, those of you who tried some, how were the questions?
They're easier than I thought they would be.
Cool. That's cool.
Like I thought I wouldn't be able to do any.
Oh,
Yeah.
excellent.
I need to rely on my calculator more, honestly.
You do, because you're gonna have your calculator, and
I took too long because I didn't trust my calculator.
Well, that's what comes with practice, right? So yeah, as well, another resource you might consider looking at as well is on the AP site, like the AP Classroom. They're probably putting out a bunch of resources right now. I'll take a look at those at some point in more detail later. But in the meantime, we got a whole month, right? So I think it's probably really good to just do any and all problems, including the ones that are officially not covered. Because as I say, it almost feels like a lot of work and mental effort to sift through the old questions and figure out, okay, is that going to be on it? Is that not going to be on it? Oh, part A is applicable, but not B and C, So might as well just do it all because we've done the whole course officially at least. Is that cool? So let's see. Okay, so I'm going to try this funny software again. Oh, we got another joiner here. YY. And yeah, cool. All right, so let's try this. So ad writing. Hi, everyone.
Oh.
Hello. So you all see that? Cool? Yep. Okay, you all see the handwriting? Okay. So why don't we then get a series of questions that you might want to see first? And well, I think we'll keep it from those 3 exams for now. And then, yeah, okay. So any requests before? Because if not, I'll choose some as well. Any requests? No ideas? No. You can unmute yourself and suggest something, or not. Okay. Yeah. By the way, headphones are really good if you can. Okay. So you want me to pick one then?
Yeah.
Okay. Cool. Okay. Cool. That's a volume one. Maybe I won't do that right now. But okay. Particle along an axis. Yeah. It's okay. Yeah, that's cool too. Okay. So how about then, let's unzoom this a bit. 2003, number 3, would that work?
Mm-hmm.
So 2003, number 3. Now, do you want to like dive into this one, or do you want to, or do you want me to just do it straight up?
You could try it.
You're gonna do it a little bit, okay?
Sure.
Cool. So this is a table of values problem. So quite probable you'll see a table of values problems, and we haven't done many of these, so certainly not much of this in the textbook problem. So you want to give it a little go? Okay, 2003, number 3. Let's go. I take it you've all got access to the tests, right? Do you? On your screens?
Yeah.
I mean, I can put it on here if you want. Here, so that helps. But just that's going to disappear at some point, right? So it's much better if you have like, normally I've actually photocopied a bunch of them and give them to you, but that's not going to work today. So there's the question. And while we're going along, I'll just point out, don't forget the units, okay? On AP problems, they do care about units. Yes, there are a bunch of units in this problem, so don't ignore them. So to the people who just joined, we are currently working on the exam 2003, question 3. I think this is on the screen share. And I'm going to go over this in a little bit of time, okay?
Hey, Mr. Sheldon, sorry I'm late.
No worries. No worries, Will. I recognize your voice, I think. Okay.
Are we doing question 3 right now?
Yeah, 2003, number 3. So it's like it's a table of values type problem. So I thought that would be something you haven't seen in a while. So it's probably good to know. I think there's someone with parent talking in the background. If you could mute yourself, that'd be cool, please. Thank you.
Okay. Oh, oh, by the way, how long is this meeting? And how many questions are we going to go through?
About 80 minutes, as many as we can get. Yeah, it'll probably be 3. It'll get more efficient once I'm confident that all of you have tried problems, but I have a feeling I'm asking you to do the problem right now because I'm willing to bet that most of you didn't. Yes. So that's why I'm doing this.
I spent most of my time doing like the chapter 9 homework.
Yep. That's okay. That's cool. But we've really got to concentrate on these old AP tests, to be honest. I'm serious right now. You have to put most of your effort onto old AP tests. This is the phase because the previous material, although it is strictly speaking applicable, this is the phase of the course where we must start to concentrate on the test material itself. And the AP exams are a slightly different creature than what you have seen on most of your previous homework, right? So I really want you to practice on old AP tests if you don't mind. Okay, highly recommend it.
Yep.
Mr. Sheldon, could you scroll up a little bit
Oh.
just to see the graph?
Oh, sure, yeah. Is that good?
Yeah, that's good.
Cool.
Just pull it up on the Moodle.
Yeah, you can download.
Like, just like
you can download it.
split your screen, I think.
Yeah, you can download it or print it.
That way you can see all the way to the bottom of D and the top.
Yep. Okay. Yeah, it works. And if you're curious, the next one we're going to work on is question 4 on the same test. Okay.
Yep.
Why does this one look familiar?
Cool.
This is what I did that problem.
Oh wait, yeah, we did.
Yeah.
Yeah, it showed up in one of the assignments.
Yep. That's cool. I like it actually. It's a neat problem. There's some really core AP skills in these 2 problems. Very important skills that are likely to be useful on the test, I would think.
Mr. Sheldon, after these 2 questions, could we do 2002 number 2D?
Sure.
Just the D part, because I had trouble
Okay.
setting up like the window screen. I wasn't sure like the value range because it kept giving me errors, so I couldn't find the 0.
Okay, I'll have to at least scroll through the first parts if I go over that question just to get everybody on the same
Okay.
page with it. But I don't also have a graphing calculator with me, so that actually sucks. I have to get a simulator for a graphing calculator, to be honest. I don't have one right now. I should have brought one home, actually. I'll have to go into the building next week and get one. Yeah, I think I need a graphing calculator so I can help you as well. Yeah. Okay, so 2002, number 2D. Cool. That, and those three, that should be enough for a whole tutorial, I think. Oh, yeah. Okay, so do we want to go over?
Mhm.
Do you want to go over
Okay.
the current one? Okay, cool. Let's see. All right,
Let's do it.
let's do it. Okay. So yeah, this question caught my eye because, as I say, it uses a table of values, and most of our homework has not covered table of value type problems. Okay. So first off, use the data from the table to find an approximation for R prime of 45. So R prime, now, if I can write on the graph, I guess this is probably not too bad a thing. Let's just zoom it in here. So if we want, this is basically the slope of the tangent line of R, right? Oops. Click, zoom, zoom. Let's look on the graph for a bit. So R prime of 45. So if I go here.
It's that basically straight line between
Yeah. Yeah, so it's like
40 and 50.
Yeah, 45 is there and there. So if you look on the table of values, of course, 45 is in the middle here, right? So what you in essence want to do is you take these 2 points, which are at 40. So I don't know if these, it's like 40 and 50, right? And then you find the slope of that line.
Wait, are you sure? I think it might be the dot that's already there.
Oh, it's, yeah, well, it doesn't matter. I'm looking at the table of values anyways, right? Just look at the table of values. I don't know about the graph or not, but it doesn't matter. So the point is you want to take those 2 points and those 2 points and use that to find a slope, right? So if I can clear the screen here and then move it on up, mouse. So here, so what we do, so sorry. So the rate of function, so R prime of 45. So what you in essence want to do is you want to, let's see here. So it's basically, yeah, R of 50 minus R of 40 over over a 50, obviously 50 minus 40. And what is that?
1.5.
1.5
And then units, please.
gallons per minute.
Per minute.
Gallons per minute squared.
Yep.
Yeah, that's cool. Gallons per minute squared. Okay, so that's cool. And the way these questions work is they're out of 9, and you're given 15 minutes to write them. That one was out of 2, by the way. So that's 2 points. And yeah, you would lose points if you didn't give the units. So it's kind of an unnecessary way to you don't want to lose marks for not writing units. So that's A. Now as for B, okay, the rate of fuel of consumption is increasing fastest when T equals 45 minutes. So now if we look at this graph here, you know, the rate is increasing at the maximum at 45. So 45 is like here, right? What that's saying is, in essence, the slope of the tangent line is at its biggest at 45. Yes, so it's at its maximum.
The slope of the tangent has a maximum.
So
That
thus,
means that the other, thus, yeah.
that means that our double prime of 45, what would it be equal to? The rate of change
Zero?
equal to 0. That is the this is the rate of change
of the rate of change
of R prime, right? So the R prime is the slope of that rate graph, yes? And so the rate of change of that slope of a tangent line reaches a maximum of 45. So that means the rate of change of the rate of change would be 0. It's the turning point, such as it is. And so, yeah, okay. Fair enough. C.
So that's all the explanation you need to write?
Oh, I guess you could say R prime of T has a maximum.
I just said explain your reasoning.
Yeah,
No,
this is explained. R prime of T has a maximum at T equals 45. That's why. Okay, that's good enough. That's cool. It's got a max there. Cool. And this, this writing software seems to be working this time. It was glitching out last time I tried it because my computer was I was using QuickTime to record the screen, and it was bogging down the computer. So now it seems to be working fine. So, okay, now approximate. So the question now here is approximate this integral using a left Riemann sum. Okay, so using a left Riemann sum on the 5 subintervals. So we're doing this. So we're going to go. And then
that means these rectangles, right?
Yes, using rectangles.
Draw rectangles.
Yeah.
With the left corner attached to one of the points.
Is approximately equal to something, right? So I'll even draw something, if you don't mind, a picture on here. Maybe this might help. Pictures are always helpful. Now let's change our writing software here so I can write on the graph. Okay. So it's a left Riemann sum, yes, which means, okay, it's a Riemann sum first, which means rectangles, yeah? So a left Riemann sum uses the left side of the rectangle where the left side of the rectangle hits the curve to determine the height of the rectangle. So thus we get, there's our first one. See, the left side of the rectangle where the left side determines the height, yes? And then here, there's our next one. You don't have to do this for the test, by the way. I'm just doing this for teaching. Because heaven knows you wouldn't have time to draw such a thing. So there. And then here. And then there. And then there. And then there. Right, so yeah, I can't draw a straight line on this graphing tablet very well, but that's okay. Oh, who's joining? Elena, welcome. Okay. There we go. So that's
have you tried using annotations?
Yeah, this works. Yeah,
They just got little rectangles that you can draw. I noticed.
Yeah, it's okay. This will work. So I will clear that off because it's not going to go away, right? But you see those rectangles? So it's like the height, times the base. And you'll notice here the bases are different, okay? So I think when we did rectangles in class, we tended to go like delta x, assume delta x was the same throughout, right? But here, our base, our delta t, they're different. So you have to really pay attention to this. You do not have a universal delta x. As well, if you don't mind, could I just use this as an opportunity to maybe review some other things that aren't on this question? Okay?
Sure.
Okay, clear enough. Now, that was what I just drew in a race were left rectangles, okay? Now, if we had right rectangles, that means that it would look like this, right, like that. So that's a right rectangle, bum, bum, yes, and then so on. Yes, you get the point, right? Okay, so that's a right rectangle. That is not what they asked for in this question, but just FYI, that's what a right rectangular Riemann sum looks like, yes, as well. So if I could erase this.
Sorry, Mr. Sheldon, why is the delta t not the same for this one?
With the delta t's, well, look
It keeps changing.
Look at the table, right? 0 to 30, and from 30 to 40. So that's a change of 30, and then that's a change of 10, and that's a change of 10, and a change of 20, and a change of 30. You see? Is that clear, William? If you look at the table.
Yeah.
Right.
I just did the 90 minus 0 over the 5 intervals, and that's what
20,
I thought.
by the way.
No, you don't. Well, you have to do them individually. You have to do actually 3 separate rectangles. I picked this problem because it's so different than most of the ones we end up seeing in our homework, right? So this is the zone, and this is also why I need you to be working on AP problems. And then if you find out that you have trouble with the problem, then you can review that material more a bit, fine. But I really want to concentrate on AP problems per se, yes? So we've seen a right rectangle here, yes? So let's clear that. What's the other type of Riemann sum we can, whoa, sorry, didn't want that.
Midpoint, right?
Midpoint, yes, good, midpoint. So midpoints are also quite common, all right? So now this data table is not amenable to using a midpoint rule, but you can definitely get different data tables that are useful for the midpoint rule. And what ends up happening, okay, is that you would be given different points. Like you would have to, if you would, for the midpoint rule here, if you wanted to use a midpoint approximation for that 0 to 30 rectangle, you'd have to have the value at 15. Do you see what I'm saying? Anyone?
Yep.
Right?
That's right.
So what value is missing here if you wanted to use the midpoint rule here? What point?
35.
35. And here, what are you missing there?
45.
45, yes. And what are you missing here?
60.
60. And what are you missing here?
80.
80. Yes, you see, right? So you'd have to have a different data table, okay? And then if it was that, then you would be like, you'd have here, so that's at 15. So you'd have that point and then that point there. Right, like you see how that works, right? And then you'd have that point there and then, right? You see what I'm saying? And then the midpoint there, you would be given that point, and then that would be the head of that rectangle, yes? That's the midpoint rule, yeah? Does this work? That's good. Okay, what's the other way we have of approximating a rectangle? Like, let's clear this. So we have left, right, midpoint. What's the other one? It's not really a rectangle. Here's a hint. Trapezoid rule, yay. The trapezoid rule, good. Now, for the trapezoid rule.
And you're so smart.
Hey, that's good. Okay, so the trapezoid rule. Now, the trapezoid rule, you could easily use the trapezoid rule for this data, okay? Now, here, for the trapezoid rule, what you end up doing, I hope you don't mind this. I know it's going off track for the question, but this is a really important, this is a really good time to discuss these things, I think. So the trapezoid rule goes like this. You have the 2 points here, right? And then what with the trapezoid rule is instead of doing a rectangle, you do that. That's horrible. Can I do that? There, you see that? So that's a trapezoid, yes? And then what's the left height of that trapezoid? What's the left side? That's, how long is that?
20.
20. And how long is that one?
30.
30.
30. I'm not going to do all of them here, by the way, but I just thought this would be a good thing. Now, in the textbook, I think there's a shortcut for using the trapezoid rule where you just, you know, it's where you memorize this formula. Don't do it, okay? Don't use the textbook shortcut. When finding the trapezoid rule, using the trapezoid rule, do them one at a time. Yes. So what's the calculation to find the area of that trapezoid then with the 30 and the 40? Oh, what's the base? The base is, of course, how big is the base?
Well, you go 30.
30, right? So what do you do? What's the
Well, you take the-
calculation?
Multiply by the average of the heights.
The average of the heights, right? So you take that.
Yeah.
I'll do the lower first. Okay, so it's 20 plus 30 over 2, the average of the heights multiplied by
times the base.
Times the base. So that's that one trapezoid, right? And if you were using a trapezoid, again, for these data tables, you do them one at a time, okay? You do them one at a time, yes? So it's the average of the heights times the base, you know, for however many trapezoids you have. Is that cool?
Mm-hmm.
Cool.
Okay, all right.
Mhm.
Okay, so I hope this is sticking. I'll clean that off now and let's go back to the problem at hand. Okay, so what we wanted to do here is we're wanting to approximate. Let's see, I need to have the mouse back. Click. Okay, so what we need to do here now is you're just going to do those rectangles, right? So remember, for the first rectangle, the base is 30 times the height, which is what? For the first rectangle? No,
20?
maybe
20.
it's 20,
20.
right?
20.
Yeah, maybe I should redraw this again just to, okay, so here it is. So this is what we're doing. Bum, 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 bum. Like that. Okay, fine. That's probably enough. Okay, so that's what we're doing right now. Okay, so clear. No, don't clear mouse. Okay, so what we end up doing here is this. So the next one, plus what? What's the
30
base?
times 10.
The base
30 times
is
10.
Yeah, the base is 10, and the height is 30.
30.
Plus what? Base is what?
Another 10.
Another
40 times
10
10.
times
And
40
then 40.
plus
A 20 is
20 times
55.
55.
55
And another 20 times 65.
plus 20 times 65, which is equal to what, please?
3,700
gallons.
Yeah.
Somebody said 3,700.
30,
Yeah.
3,700, right?
I mean, that's
3,700.
the same thing.
It's the same thing. Yeah, that's cool.
I know.
Okay, so
It's
now,
funny because it's American.
Okay.
okay. So if we look at that picture, is that an underestimate or an overestimate?
Underestimate.
Underestimate.
So it's an underestimate. Why?
The graph is
It's
increasing.
the increasing
Yeah,
graph.
the graph is increasing. So R is increasing. Like the graph is increasing.
Okay, so how do you write that as an explanation?
R is
Like
increasing.
in words.
R is increasing
Okay.
on the interval.
And for the unit of the answer, is it gallon?
Yeah.
Yep.
Okay.
Yeah, that's gallons. Yeah. Because it's gallons per minute. It's gallons per minute. Yeah. And again,
Times minutes.
yeah, no, it's just gallons. right? If you integrate, recall here, right? If we integrate the rate of something over t1 to t2, right? dt, then that is the change over
The total change from T1 to T2.
Yeah. From, whoa. Oh, I had this problem before, didn't I? Okay, it did this to me last time. That's okay. Let's see here. There it is. Okay, I figured out how to get out of that little lock there. Okay, so yeah. So what we do is this is the change in R, in the original quantity. Quantity over T1. Whoops. Right? So, because R is the rate of change of something, in this case, what volume, I guess, or fuel consumption, or it's just fuel consumption. Okay, so cool. Now let's go on to the next one. Okay. So now clear. Okay, over that time, explain the meaning. Oh, we just did that. Explain the meaning of it. Okay, fine. So, yeah. So we just kind of answered that, right? Didn't we? So that is this is the fuel consumption.
Well, it's between 0 and B this time.
Yeah. Yeah. Over the first B minutes, right? Okay, so it's the fuel consumption over the first B minutes. And what is that second one? So
the average.
It is the average. So 1 over B, the interval of from 0 to B of the rate dt, right? So that is the average rate of change. So that's the average of the fuel consumption. It's the average value of the fuel consumption of R over the first B minutes. Okay, so whereas this one, 0 to B, R of T dt, this was the total fuel consumption here, yes? But then if you divide that interval, like the total fuel consumption, by B, if you multiply it by 1 over B, that is the average rate of fuel consumption. You see you see the difference? Yes? Are we good?
Yeah.
Because you divide it by minutes again.
Yes,
yeah,
exactly.
You use the gallons per minute.
Yeah, it's in gallons per minute, and it's in the units, it's gallons per minute.
Yep, thanks.
Yeah, so that's in gallons per minute, whereas this is in gallons. Right? Units are important, yes. Cool. Yeah, and units, units are given marks here. Okay. So cool. So would you like to work on question 4, please? On the same test, please. So that would be this question, for those of you who don't have it. I'll expand this out a bit. So that one, okay? I like this one. By the way, I might point out in that problem, they say that average value isn't on the test. Well, who cares? Like, why don't we just do the whole problem? You can't just pick. It's difficult to pick out individual topics, like say, oh, average value from a question and say, oh, I don't need to study that now. It doesn't work that way. It's not the way you learn. So just do them all, and be aware what's not really going to be on the test. Yeah, like average value not on the test. Okay, fine. This is a good problem. I like this kind of thing. All right.
Oops.
And the equation of a semicircle is I think it's got something to do with square roots. answers.
How are we all doing?
Good.
Cool. Yeah, I've chosen these problems because I suspect
Of
just
course.
knowing what you've studied, knowing the way we've covered things, I know these problems are going to be pushing you a bit, and they're also really common. And they're also problems where you can get good at them after a while. They just cause you to think in a particular way. And yeah, they're pretty central. I mean, it's basically like curve sketching, only, well, there's some integrals too, but yeah, it's a lot of the ideas we had in curve sketching with a bit more. But it's extremely good practice, these problems. And I see this type of problem a lot on the AP test. And to be honest, I suspect this type of thing will be probable on the test because this is a very central problem. It's like right in the foundation of this whole course. So knowing these ideas can't hurt. Yeah, I know. In the future, folks, I know I'm giving you a lot of time to work on this. In the future, like is in the next tutorial, I'd like to assume that all three of those tests have been done, in which case I can spend my whole period just doing them. Is that cool? Right? Or I understand, you know, I'm sort of allowing for some of you to take a little extra time to do this. But yeah, on the next tutorial, can we assume that you get all three of those tests done? And then I'll now give you another practice package. And then, yeah, once we've got a foundation of a whole bunch of tests under our belt, I can just rattle on without pausing, without having you work on them right now. But I just don't think it's useful for you if you haven't seen the problem before to just do it. Okay. Are we about ready? Okay, so let's go. Okay. Are we ready?
Yes.
Yes? Cool. Okay. So the thing about this is that it is, let's see. Okay. So the thing about this is this is the graph of the derivative of f, right? So, and then we're talking about the original function, which you are not given the graph of, right? So we're talking about f, but this is not the graph of f. This is the graph of f prime. This is the graph of the derivative. So in this case, on what intervals, if any, is f increasing? Okay. Well, if you are
positive.
Yeah, increasing, right? So increasing, fine, I'll just do it up here. Increasing, or f is increasing. Means f prime is positive. Yes. So f prime greater than 0. And where is f prime greater than 0? Please. Where is it?
-3
Negative
to
3 to negative 2.
-2.
Yeah, that's cool. Right there, right where it's above the axis. Okay, cool. So yeah. So that's cool. So that's A done basically. And the justification is to say that the derivative is greater than 0. Yes, you got to write that. So it's increasing on the interval, -3, -2, right? Okay, since f prime is greater than 0 on that interval. So that's your justification, to say that f prime is greater than 0 on that interval. Okay, find the x coordinate of each point of inflection. So let's clear this off. So the x coordinate for each point of inflection.
Also, Mr. Sheldon, sorry.
Yep.
Would when you're talking about the period on which f is increasing, would that include -3, or is it only when x is greater than -3? Because it's a closed point.
Yeah.
No, it's definitely
fine.
negative.
The -3 maybe.
So it does include negative,
it's
but
got-
not -2.
Yeah, not -2.
Yeah.
Yeah.
Okay.
Okay. So that's cool. So find the x of each point of inflection. So point of inflection. So here, if I could write it up here, a point of inflection well, to have a point of inflection, you need, first off, the point needs to be in the domain. Okay, well, so it needs to be in the domain, and you need f prime to change signs. Right, so f prime changes sides. F double, or you need the. No, that's wrong. Okay, fine, whatever. So you need a derivative sign change. So yeah, no, it's f double prime changes sides.
That's right.
Yeah, it's right. So f double prime changes signs. You're given here the graph of f prime, right? So this is the graph of f prime. So f double prime is the slope of the tangent to this. Yes? Okay. So where does the slope of this line change from positive to negative, or from negative to positive? Anyone? Where does it change sign? Anyone give me a value?
X equals 0.
X equals 0. You see,
Right.
because at that point there, here the derivative, the slope of the tangent line of f prime is negative. So this is like f double prime is less than 0 over here, because f double prime is the slope of the slope of this f prime graph. Yes, I know this is slightly disorienting because there's so many primes going on, but this is the graph of f prime, and then here we have that. Okay, where else is it? I saw a little red circle. Somebody could do that. That's really cool. So the other one is here, right? Because we go from positive. This is f prime. Yeah, nice. That's cool. Who does that?
It's annotations underneath the view.
That's cool. Is less than 0. Yes?
I was wondering if you guys could actually see that, or if it was just on my screen.
No, they can see it. Yeah, we can all see that. That's cool.
Wait, how do you do that?
It's under annotations. It's when you scroll your mouse over, you are viewing screen, and you change to view options.
That sounds
dangerous. From view options down to annotate.
That sounds dangerous, actually.
Very dangerous.
Oh God! One more reason to use Microsoft Teams.
Other people's stuff.
Yep, that's interesting. Oh God. Uh-oh. Okay, I'm gonna have to. Okay, folks, this is. Okay, so I trust this class, but oh dear Lord, what have you done, Drayden? Okay. Yeah, fine. So here, I'll clear that at least. And then, okay, so fair enough. So it's there. So can you please clear that now? Or,
Doesn't know how to clear it.
Just
Yeah,
click the
that-
clear button.
You
It's
know,
on the. Yeah.
there we go. And there's got to be a way I can turn that off. But I don't know what it is right now. But I will figure that out in the future. But thank you for finding that. By the way, could I ask you another question about Zoom? Because I can't see the user side of this. Can you folks see each other's profile pictures voluntarily? Can you choose to pull up your own profile pictures? Or because I've pinned my picture up here, right? Like you see my face, me talking on the top right-hand side. Can you pull up anything else about anybody else besides in the chat?
I have no idea.
Okay, well, if you can't, that's good. That's what I want to know, but I want to know whether it's possible.
Can I pull up anything? What? What do you want me to pull up?
Someone else's profile picture or photo, because I pinned this one right now.
I believe you can do that. Yeah.
Yeah.
You can do
You
that.
can, but you can also just choose one person to be your, like, whoever you want to.
Yeah, I know, but I want control over it though, right? So I'm gonna
Well,
have
you
to.
can go to the participants screen, but nobody's currently on video right now.
Yeah. Yep. Okay, so you can pull up on participants. Okay, this is another reason why I'm using Zoom. Using Zoom might be a little iffy. This is why Teams might be the. Yep. This is why Teams might be the solution for well, some of my classes at least. Okay. Yeah. So anyway. Okay, fair enough. Get rid of that. Cool. Now, please. Okay. Can you? Thank you. So as for okay, this is good. So as for an equation for the tangent line at this point, okay. So the way we do this one here is, if I could pull this up here, and new page. There we go. All right. So as for the equation of the tangent line,
Slope point.
Yeah. Where is it? We're on that one. Okay. So here, find an equation for the tangent at 0, 3. So for part C, this is a pretty simple problem. You've got a point on 0, 3. This is on y equals f of x, right? So you don't have the graph of y equals f of x, but you have a point on y equals f of x. And then all you need to find the tangent slope is the derivative f prime at 0. And you can just read that from the graph, right? So you read that from the graph. What is the slope of what is the derivative at 2?
-2.
-2.
-2, right? So -2. Okay, so then it is basically y minus 0 equals -2, x minus 2, a infinity, right? Oh, no, that's
what?
No, that's wrong. Jesus Christ. Okay, y minus yeah, is equal to -2, x minus 0. Fine, cool. My bad. Okay, a little bit disoriented because of all the technical things here. Okay, cool. And then D. D is the real one I wanted to just discuss. So D is this. So D. So D, we go f of -3. I want the value of that, yes? So I will remind you that the value of the function f of, say, x will equal the value of the function at some point, which we know f of 0 is 3. So we know that's 3, right? Right there. Plus the change from 0 to x. And then I can just put in a placeholder variable, but it is basically f prime of, I don't know, t dt, just to keep the variables consistent. Yeah. So I'll remind you again. So this is the start value. And this is the change from 0 to x. Change from 0 to x. Yeah. that make sense? So then what we do is if we're looking for f of -3, so f of -3, and so that is equal to the start value, which is f of 0, which was what we know it, plus the integral from 0 to, right, to -3. And then we can go, f prime of, I'll just use t just so we're not confused here, okay? But t is just standing in for x. All right, so here we have this stage where we're going backwards on our integral, right? So if you'll remember, do you remember the rule where you switch the limits of integration and then you swap the sign? If you remember that?
That's right.
Okay,
You
so
drop
what we
the
can,
negative out.
you drop the negative. So this is basically 3 plus the integral from -3 to, oh, geez, it's minus, right? So I'm just gonna cross that up, minus, and then -3 to 0, and then f prime of t dt. Yes, whoops. And so this integral is basically just a straight off area, right? So if we can go back to the graph for a second here, all right? So on the graph here, what we need to do, we basically
find the
this
of the line.
area, so the integral of it's the area under the curve, right? So it is basically, okay, that one is 1/2 base times height, right? So the height is -2, the base is 2, so that's 2, and that's -2. And so 1/2, so obviously this integral is -2 in here, right? And then this one is what?
1/2.
1/2, right? So that's 1/2, positive 1/2. So the integral going from here to there, the integral from going from -3 to 0 is 1/2 minus 2. Yes. And so, so we have to really be careful of the plus and minus signs. Yes, right. See, if you're just doing the integral in the normal direction, going from small to large, from -3 to 0 here, right? You just take the straight off values. So what we do here on the graph, if I can go back to the paper here.
Since you're subtracting, you're adding it.
Right.
And so you add 1.5 to 3.
Yeah. So it's basically 3 minus, and then 1/2 plus -2. Does that make sense? Because that's the area read straight off of the graph, yes? So 0.5 plus -2 area, right? Or -2 integral. And then you subtract it because originally you were going backwards. So what does that come out to, please? Anybody? You have a number? That's equal to what?
9/2.
Yeah.
Does anyone else want to say 4.5?
9/2.
Yeah, 9/2.
9/2. Yes. Okay. And and then for the 4, so that is basically f prime, f of -3, right? And then here,
I totally didn't realize I was supposed to use get the rectangle and then subtract the semicircle.
Yeah. Yes. Oh, yes. True, isn't it? That's a little bit odd. Oh, I can see how you'd messed that one up totally. So that's f of 0 plus the integral from 0 to 4 of f prime of t dt. And so now what we need to do here is we'll go back to the picture, right? And what we're going to do is this is actually a really tricky problem. So if we go back to the picture here, right? What you end up doing here, you're actually looking for those areas, yes? That's the integral from 0 to 4 f prime of t dt. Excuse me for substituting x for t. So that is the integral, like that plus that. And the way you do that is you go a semicircle, and the radius is 2, right? So it's like pi times 2 squared. No,
Well,
that's,
you take the
that's backward.
rectangle
You
of the
subtract
outside,
it.
and then you
Yeah,
subtract the inscribed.
exactly. So what you do is it's this rectangle here, which is 4 times -2, right? Okay, and then minus this, minus the pi r squared. So minus the, actually, no, it would be plus it, wouldn't it? It'd be plus pi times r squared, yes? Am I right?
Yeah, minus.
Minus, right? So because it's below, so you can't just put, the negative doesn't go inside the r, of course, right? But it's basically, first off, okay, here's your reality check. You know it's below the x-axis, so it's going to be negative, right? So it's going to be negative. And then, so you're taking the rectangle, which is a big giant negative number, and then plussing the half circle, right? Making the size of the number
As you
big.
said, graphical area. So if you multiply the -2 by the 4, you get a -8 total.
Yeah. In any case, the final results, and I'm going to have to wrap it up here, right? So the final result, if I can go back to this.
And you divide by 2. It's a semicircle, not a circle.
Yeah, it's a semicircle. Yeah. Over 2. My bad. Thank you. Over 2. It's a semicircle. Yes. Sorry. So then we got, like, obviously I'm doing this at the same time you're doing it. So this is basically, it's basically -5 plus 2 pi. It comes out to be -5 plus 2 pi.
Yep.
Okay. Fair enough. I have a feeling a lot of you will have had a bit of trouble with this problem. I hope you don't get too discouraged, because I picked this one because it has a lot of value in covering your blind spots, which I suspect a lot of your blind spots are included in this problem. Don't worry too much if you had a little bit of trouble with this, but to see if you can figure out what I've done, okay? But yeah, I don't think I have time to do too much more than this, if you don't mind. I'm sorry, somebody asked about the graphing calculator problem. I don't even have a graphing calculator with me.
Oh, it's okay. I figured it out. I accidentally put like the maximum or minimum switch, so that's why I was giving me an error.
Oh, okay. Well,
Yeah,
I'm
good now.
I'm going to try to get an online graphing calculator that I can put on the screen here so that you can all see it. That would be ideal. TI doesn't make it terribly easy. So there used to be a bunch of them for free, and now they're not allowed. So I have to find one, but I will. In any case, next week, another tutorial, if that's good. I hope this works for you. And it'll probably be a lot more of me doing problems next time, okay? So would you like to have finished maybe 2001, 2002, 2003 by next tutorial? Is that good? Hello?
Sounds good.
Yeah.
Sounds good.
Yep.
Yeah.
Is
Okay.
it going to be on Tuesday?
Possibly. Yeah, possibly on Tuesday. Okay. At some point, I'm going to try to jump to Teams, but it's not just me. It's other people have to set it up. I haven't even been switched on for Teams yet for meetings. So yeah, and then I have to learn how to do it, which is a different problem. But anyway, thank you all for showing up. I hope doing this problem, this stuff is helping your state. You know, I know it's difficult being locked up in this quarantine, but yeah, we'll be okay. We'll get through it.
Thanks for inviting us.
You're welcome. It's been my pleasure. And as I say in the email, it won't go on forever. And remember, all these people who are writing this test, this very strange test, are in the same boat as you. I think I've heard that maybe the lowest mark is a 3 too on this test. I think all the marks will be considered 3, 4, 5, but I'm not sure. But I've heard that on the Facebook chat, or at least the AP teachers Facebook chatter, is the marks will be 3, 4, 5. And getting a 5 mark is actually probably easier than you think. Okay, so you know, I just have some faith. This is actually probably a good year to be writing this test, to be honest, because they're going to be I suspect they will be very charitable. I can guess that. Okay. So just, we'll push through this. We'll get through it all together. And yeah, I hope you're going to be okay, and have a good weekend. Try to get some exercise. I know it's hard, but try, and just take care. Okay. So I'll post the meeting details on Moodle next time.
Thank you, Mr.
Thanks,
Shola.
Mr. Chang.
You're welcome. Take care. It's a
Thank
pleasure.
you. Bye.
Have fun. Bye-bye.
Thank
Until next
Take care.
time.
Till next time.
Thank you.
Bye-bye. Thank you. Bye-bye.
Yeah.
Boink. Okay.